Next topic is some properties of divisibility. A, B, C, D are integers, and first theorem is what? If A divides to B, then we have to show A divides to Bx. Then A divides to B and A divides to C. Then A divides to B plus C. Also A divides to Bx plus Cy for x and y, for any x and y belongs to Z. And this is A divides to B and B divides to C. Then A divides to C. And now we have to show m is not equal to 0 in Z. A divides to B, then am divides to bm. A divides to B and C divides to D, then AC divides to BD. AC divides to BD. And AB divides to BC, then A divides to C. So the proof of the first, that A divides to B, then we have to show A divides to Bx. So what is given? A divides to B. So what is its meaning? B expressed in the form A into some integer. Either use C letter or K letter. For some C belongs to Z or some K belongs to Z, because A divides to B means B expressed in the form A into some integer. Use K letter or C letter. Then we have to show A divides to Bx. A divides to Bx. When A divides to Bx, if Bx expressed in the form A into some integer. So here is B is AC, and so multiply both sides by x. So what do we have? Bx is equal to ACX, and then write in the form at A in bracket CX, and this C and X both are integers, and therefore CX is integer, and that is we did not CX by either C dash, and where this C dash or CX is integer, and therefore this Bx expressed in the form A into some integer, Bcx is integer, or Bx expressed as A into C dash, for some C dash belongs to Z, and therefore A divides to Bx, because Bx expressed in the form A into some integer means A divides to Bx, by using the definition of what? Divisibility. What is the definition of divisibility? This is the definition of divisibility. That is, A divides to B if and only B is equal to AK for some K belongs to Z. That is, if B is equal to AK, that is, if B expressed in the form A into some integer, it means that A divides to B. This is two-way statement. That if A divides to B, then we have this. And if we have B is equal to AK for some K belongs to Z, then we say A divides to B. That is, if B expressed in the form A into some integer, then we say A divides to B. So here is we have Bx as A into some integer means A divides to Bx by reverse use of this definition. That is, B is equal to AK, then we say A divides to B. That is, B expressed in the form A into some integer, then we say A divides to B. So here Bx expressed in the form A into some integer means A divides to Bx, and that is we have to prove. That is, A divides to B and A divides to Bx. Now the second is what? A is divides to B and A divides to C, then we have to show A divides to B plus C. So since A divides to B, we have B is equal to A into some integer. So use K1 as an integer. And also A divides to C. This is assumption that A divides to B and A divides to C. And A divides to C means C expressed in the form A into some integer. That is, suppose K2 is that integer. Okay. And then we have to show A divides to B plus C. When A divides to B plus C, if B plus C expressed in the form A into some integer. So consider B plus C. And what is the value of B? Is AK1. The value of C is AK2. And take A as common. This K1 plus K2 indicate this K1 plus K2 by K. And obviously K1 and K2 are integer. Therefore K1 plus K2, that is K is integer. And that's why what we have, B plus C expressed in the form A into some integer. A into some integer. And therefore A divides to B plus C, because B plus C expressed in the form A into some integer, and therefore A divides to B plus C. Okay. Well, we can also show that if A divides to B and A divides to C, then A divides to B minus C. Obviously, very simple. That is, consider here, write the meaning of A divides to B, that B expressed in the form A into K1, C divides to A divides to C means C expressed in the form A equal to, and then consider B minus C, that is AK1 minus AK2. Take A as common, and then K1 minus K2 indicate by K. Obviously K1 and K2 are integers, and subtraction of two integer is integer. Therefore K1 minus K2 is integer, and so B minus C expressed in the form A into some integer means A divides to B minus C. So we can also show this, that A divides to B and A divides to C, then A divides to B minus C. Now we have to show this second sentence, that that is what, if A divides to B and A divides to C, then A divides to Bx plus C, where x and y are integers. So again write the meaning of A divides to B means A divides to B means B expressed in the form A K1, and A divides to C means C expressed in the form A into K2 for some K2 belongs to Z. And then consider, instead of this B plus C, consider bx plus c, ax plus by. Consider ax plus by, or we can use the number one theorem to prove this sentence, that a divides to bx plus c. Or consider bx plus cy, like this b plus c. Consider bx plus cy. What is the value of bx plus cy? Bx plus cy, substitute b as ak1 and substitute c as ak2, and therefore, and take a as common. So what we have in bracket, k1x plus k2y, and indicate this k1x plus k2y by k. Obviously this k1x plus k2y is the integer, because all k1 k2 x y are integers, and addition and multiplication of integer is integer. And then what do we have? Bx plus cy expressed in the form a into some integer means a divides to bx plus cy. Okay. Or another proof is what? As a divides to b implies a divides to bx for some x, for any x belongs to z. By using this, a divides to b, then a divides to bx, and therefore a divides to bx. And also as a divides to c, for any y, what we have? A divides to cy. And by using one, that is, if a divides to b and a divides to c, then a divides to b plus c. Here we have a divides to bx and a divides to cy. Therefore, a divides to bx plus cy. Okay, so we can give the proof of this second part of this theorem by using two methods. Either use this method, or consider, that is, assume a divides to b and a divides to c. Write its meaning, that b expressed in the form ak1, c expressed in the form ak2, and consider bx plus cy, and express it as a into some integer. And obviously it expressed in the form a k1x plus k2y. Indicate that k1x plus k2y is k, and then we say a divides to bx plus cy. And also we can show that if a divides to b and a divides to c, then a divides to bx minus cy. That is, instead of this considering bx plus cy, consider bx minus cy, and I express it in the form a to some integer. So next, third is what? We have to show if a divides to b and b divides to c, then a divides to c. That is, one divides to other and other divides to third one, then first divides to third one. That is, we have to show this divisibility relation is a transitive relation. When we say that relation is transitive relation, if one element is related to second and second is related to third, and if then first is related to third, then we say the relation is a transitive relation. That is, if x related to y and y related to z indicates x related to z, then we say the relation is a transitive relation. So now we have to show if a divides to b and b divides to c. So this is given that a divides to b and b divides to c, and we have to show a divides to c. So write the meaning of a divides to b as a divides to b, b expressed in the form a into some integer. Either use x, y here later, or c, or any other. C is already there, so use k1, k2, k3, k. Here the letter is used to indicate some integer x. So this a divides to b means b expressed in the form a into some integer. Also b divides to c implies c expressed in the form b into some integer for some y belongs to z. Either use x, y, or k1, k2. And then we have to show a divides to c. So when a divides to c, if c expressed in the form a into some integer, so consider c. And what is the value of c? Is by. And what is b? Is ax. So what do we have? C is equal to by is equal to axy, and then write as b c ax. Then write c is equal to a, write x into y in one bracket. And this suppose indicate x into y by x dash. Then what we have, c is equal to a x dash. Obviously this x is integer, y is integer, and multiplication of two integer is integer, and therefore x into y is integer, and therefore c expressed in the form a into some integer indicates or implies a divides to c. And this is why to show this property divisibility is transitive property. Then next one is what? Number 4, we have to show am is not equal to 0, and given that a divides to b, and we have to show am divides to bm. So write first a divide, meaning of a divides to b. So a divides to b indicates that b expressed in the form a into some integer for x belongs to z, and then multiply, and now we have to show am divides to bm. So when am divides to bm, if bm expressed in the form am into some integer, so just multiply to this equation, b is equal to ax by m. So what do we have? Bm is equal to axm, and then write axm in this fashion, that amx. So this x is integer, and so bm expressed in the form am into some integer implies am divides to bm. Okay, because bm expressed in the form am into some integer, and therefore am divides to bm. Now the fifth number, the theorem number 5. If a divides to b and c divides to, then we have to show ac divides to bd. So first write the meaning of a divides to b and c divides to d. So a divides to b means b expressed in the form a into some integer for some x belongs to z, and c divides to d means d expressed in the form some c into some integer for some y belongs to z. And now we have to show, AC divides to BD. When AC divides to BD, if BD expressed in the form AC into some integer, so consider BD, and what is the value of B is AX. What is the value of D? CY. And so write this AX plus CY in this fashion, AC into X into Y. And obviously this, suppose this X into Y is K, then it is integer, because X and Y are integers, and multiplication of two integer is integer, means this K is integer, and therefore BD expressed in the form AC into some integer implies therefore AC divides to BD. Okay, and that is we have to show that AC divides to BD. And then the last one is what? If AB divides to BC, then we have to show A divides to C. So first write the meaning of AB divides to BC. What is the meaning of AB divides to BC? That AB divides to BC, we have this BC expressed in the form AB into some integer. So for integer, use the letter x or k or k1. Then BC expressed in the form AB into some integer. And then what is given? Now here is AC is equal to BC. AC divides to BC. Therefore, BC expressed in the form AB into X for some X belongs to Z. And then cancel this B of both sides. So what do we have? BC is equal to, right, this is B, as AB is not equal to 0 also, because AB is the divisor, and divisor is always not equal to 0, means B is not equal to 0. And cancel this B of both sides. And then what do you have? C is equal to AX. C is equal to AX, and therefore C expressed in the form A into some integer implies A divides to C, which shows that A divides to C. Okay, so just cancel the B of both sides. For that, B is not equal to 0. Required B is not equal to 0, as AB is not equal to 0, because AB is divisor. AB is not equal to 0 and implies B is not equal to 0. Okay, so just cancel B of both sides, and therefore we have this. AB is not equal to 0 means both are A and B are not equal to 0. So when the multiplication of two integer is not equal to 0, if both are not equal to 0, that's why we can cancel this B of both sides. So just write the meaning of AB divides to BC. That's BC expressed in the form AB into X, and just cancel this B. Okay, and therefore we have C is equal to X, and which shows that A divides to C. So next is the Euclid's lemma. It's very important as far as the exam concerned. So what is the question on this theorem? That state and prove Euclid's lemma. So if P is prime, so what is the meaning of prime? Prime means the numbers that are divisible by 1 or itself are called prime. So P is prime. And AB are integers such that P divides to AB. Then either prove that P divides to A or P divides to B. So this is the Euclid's lemma. And we will see the proof of this theorem in the next lecture.